Hi, in this series of videos I've been attempting to create and demonstrate experiments from this book, Make Electronics by Charles Platt, which I thoroughly recommend if you would like to build and try out those experiments for yourself. You will find a link to it in the description if that's something you'd like to do. And if you watch the previous episode, you'll know that the book has introduced soldering at this point. And you saw that my soldering skills are far from perfect. And in this episode, they're going to be put further to the test because the book asks us to build a wearable version of the multivibrator light flasher that we built on a breadboard a couple of episodes back. And wearable because the idea is that you will end up with a small circuit board with the circuit which you can attach a battery to and then attach to some clothing or a cap or something along those lines. So let's see if my soldering skills will hold up for this test and see how we get on.
So what you can see here is a version of the circuit on a breadboard. And I will just plug the positive lead in here so we can see that it's working. And as you can see here, I am using the power adapter that I suggested in the previous episode instead of a 9-volt battery, although we will use a 9-volt battery on the built circuit. Now, at this point, you might be wondering, hang on a second, you promised that this was going to be something that you would build by soldering. So why are you now showing us it on a breadboard again? Are you copping out? The answer to that is no, I'm not copping out. My personal preference is to, before I solder a circuit together, is to build it on a breadboard for two reasons, really. One is because that way I know that all of the components that I'm planning to use are working okay. So if the circuit doesn't work after I've built it, that will be down to a construction error rather than the fact that I was inadvertently using a dodgy component. The other reason, and it doesn't really apply in this case because I do have a layout for the finished construction, but if you're working purely from a circuit diagram, building it on a breadboard first does ensure that you've properly understood the circuit diagram and the connections before you then plan to build a more permanent version of it. This is purely a personal preference. It's not something from the book. It's just something that I like to do. So that being said, I can see that everything is working as it should do. So the next step is to use these components to build the finished thing. Let's do that now. So we're going to build the circuit on perforated board, which as you can see is just a bit of board with very closely spaced holes. It's exactly the same on both sides. There are no copper traces on this type of board, so you have to make all of the connections just by soldering component leads together on one side or by adding small wires as you need to. Now, the book does suggest, and I think this is probably a very good suggestion, that you build the circuit on a larger piece of board and then after you've built it, you've cut it down. I've perhaps rather foolishly decided to just cut mine first because I will use these magnetic clamps just on the corners of the board to hold it in place as I need to, and we'll see whether that works for me or not. So let's start assembling. So here is the board with all of the pieces in place. And as you can see, it is very, very cramped. Like there's no space to spare. I mean, I guess the idea is because it's supposed to be a wearable is to keep everything as compact as possible. But I do think that makes this quite a challenging first perforated board project. But anyway, really that's the easy bit, getting all the components in place, because if you look at the back of the board at the moment, it's just a mess of component leads. So I'm going to have to be very careful about making sure that I'm soldering the right bits together for this next stage. But let's see how we do. So as you can see, because one of the first components I will be connecting is one of the LEDs, I've taken the advice of using a copper clip to act as a heatsink. So I've gone back to a medium soldering tip for this work. I think the other one that we had for the wires may be a tad too large. So I'm just going to apply heat across both of the joints. A bit of solder, there we go. Now, my instinct would be at this point to clip the leads, but what the book advises is to actually leave the leads long until you've finished the circuit, so that if you make any mistakes, you're not then having to try and fiddle with leads that are a bit too short for what you're trying to do with them. So that does mean, though, just making sure that the excess leads stay out of the way of the other work that we're doing. Okay, so I'm going to carry on with the soldering work now, and then I'll come back when I've completed a little bit more. So here's all the soldering finished. Certainly not the neatest job in the world. It was very fiddly. That was certainly, so far, this has proved to be the most challenging experiment in the book. One sort of slight concern is with all of these excess leads still attached, is there's a very serious danger of introducing a short. So before testing and plugging in the battery, it's definitely worth just having a look with a magnifying glass or a microscope and just check that you haven't got any shorts. One thing that is of a particular concern is this long lead running down the center, which is actually attached to the positive lead from the battery clip. I think if in retrospect, I probably would have used a bit of insulated wire for that, because it does run very close to a couple of connections either side of it, but a bit late for that now. So I think it's just a case of just making sure that there's clearance there and that there isn't a connection where there shouldn't be one. So now for the test. Is it going to work when I plug the battery in? To be honest, I think it will be a miracle if this works. But you know, let's give it a go and see what we get. Oops. Well, how about that? Frankly, I am flabbergasted that that worked first time round. I'm quite pleased, actually, quite pleased. So the next thing to do now is for me to clip the excess leads off and then give it another quick test to make sure everything is still working. So here it is with everything trimmed down a little bit. Certainly it looks still not amazingly neat, but it certainly looks a little bit better than it was. Oh, I've just spotted one there that I could probably trim a bit more, but I'll do that later. But let's just plug it back in and just make sure that in doing that I haven't disrupted anything. No, all is looking good. So now if I wanted to, the next thing would be to somehow mount this on a piece of clothing or a cap or something. I'm not going to do that. I don't particularly have any great desire to wear a pair of flashing lights. Maybe a little bit undignified at my age, but that's been a fun experiment. So I do definitely recommend that one if you are working through the book.
I hope you enjoyed that. It's certainly satisfying to create something a little bit more permanent. So in the next episode, the book introduces us to the wonderful world of integrated circuits, starting with perhaps the most famous integrated circuit of all time, the 555 timer chip. please join me for that.